So this is the word count program. This whole code is word count program. And what you need to understand is that the MapReduce program has three parts. One is the mapper side, mapper part, where the mapper logic will be written. Second is the reducer part, where the reducer logic is there. Third is called driver. You know what is a driver? So driver is the part of the program which controls the program execution, like what type of a file you have, the main method and all will come in the driver. This is my driver. See, Java people. So I have my main method here. So this is the main method. Driver will have the main method, right? So this is my public static void main string arguments. This is a regular boilerplate code you write in Java for main method. Then what is interesting here is that, okay, this one I have commented. You have to create something called a configuration object. So I am instantiating a new configuration object. What is this configuration object? See, if I submit a program to a Hadoop cluster, look at the possibility. I created a program. Does that mean this program can be submitted only to one Hadoop cluster? No. I can submit to any Hadoop cluster wherever I have the data. So when the program gets submitted to the Hadoop cluster, it should know where is the name node running, resource yarn running. It should understand the cluster configuration. That will be read by this configuration object automatically. So Hadoop configuration is actually stored in a set of XML files. I'll show you that. Okay. So this part of the code in your driver will go and read your Hadoop configuration, whichever cluster you're submitting, and understand the cluster configuration, like where is the name node running and all these details. So this configuration object is used to read your cluster's configuration. And then you have to create something called a job object. So I'm saying that new job, I'm creating a job object. I'm passing the configuration. I'm also giving a name for my program, my first code. Any name you can give, doesn't matter. So this job object is responsible for actually running your program. Okay, and this job object has some setters. You are aware of getters and setters, right? So here I am setting the mapper class, map.class. So the mapper logic will be written as a Java class, and the name of my class is map.class. I'll show you that. So I will say that job.set mapper class, map.class, set reducer class, reduce.class. I will also say set jar by class, word count.class. This is my public class which I define. So in this job object you have to tell. This is how you are telling in the MapReduce which is your mapper, which is your reducer. If I have a partitioner, I will say set partitioner class. This is my partitioner. So here I am doing these settings, okay, and this is commented. Look at here, set output key class, output value class. So what is going to happen? What will be the output of word count? There will be a word and count. Say for example, Arya 9. So Arya will be the key, 9 will be the value. And Arya is ideally a string. I told you we don't use string. So I'm saying that the key, we are using a class called text. This is the wrapper class. Text.class. I will import it in my Java. So this is the wrapper class for my key because my string is represented as text and value is int writable. This is again another wrapper. So in the driver part of the code, you have to mention all these things. What is the data type of your key, value, which is your mapper class, reducer class, configuration, all these things you have to mention. Plus, you will also have input format class and output format class. I told you I will explain about this. So the question is that how do you read a different type of data, right? So there is an abstract class called a file format. And that abstract class or the parent class has multiple child classes to read a different type of files. And the most commonly used child class is input file, text input class. Now we have worked with text input class. There is XML. If it is XML, it will look at your root tag and row tag and extract. There is text, there is XML, there is key value input. There is something called sequence file input, and then there is binary. Understand this, if I'm having image files and all, I cannot directly process. See, look at the philosophy of MapReduce. How can I say an image is a key and value? Not possible, right? So first I will convert those images into binary file. Then there is a class called binary class which will understand binary data and read it. So that class I have to call to read those files. I cannot directly process my images or anything. Normally if you store an image and read it, okay, it is a .jpeg extension or something, right? You can't process that. That extension you cannot process. Then what you have, JPEG and GIF or a bitmap. So they will have their own encoding. You can't process it actually. That's what. The output is always key value pair. That you can mention what format. Here I'm saying it is text. Even in the mapper, you're producing key value pair. So mapper is the guy who first produced the key and value. And mapper's output is word comma 1. What is that word? It is string. I don't use string. I say that word is text. Right? I will say output key, output value. This means the final output only. But even in the mapper output, this is same applied. Whatever key and value you want to use. And this is my input format and output format to read. This execution has nothing to do with edge node. The execution is handled by somebody called yarn. The driver program will go to the cluster. Right now, your entire code is on Linux. That's jar file. When I say run, it will read and push to the cluster. It will go to the cluster. On data nodes only the program will run. Anyone can run. I mean, it doesn't have any importance, but you can track where it is running. I will show you. Once you run this, I will show you where your mapper ran, where your reducer ran. There were developers who were integrating that also, rather than manually setting, right? Yes, that is possible. This is a very simple program also. Like here I can manually set, doesn't matter. Also the variables, what you say, private public properties and all, it might be a concern, right, sometimes. So here I'm simply doing a set, I'm not doing anything else. Spring can be integrated normally. But again, coming to the point, right now nobody does, because nobody want to write a MapReduce program at all, right? Because it's very obsolete actually. One more point I want to tell you is that if the cluster administrator wants, he can decide how many reducers should run. Meaning, by default, if you simply install Hadoop, there is only one reducer which will be called for every program. A developer in a program can say, I want 5. You will get 5. In my program, I have not written anything. So ideally, it should run with one reducer. But in my Cloudera cluster, the administrator has set any MapReduce program runs by default, you will get 3 reducers. In the Cloudera, I mean, I don't know who set it. I asked it to change. Because if you just go to this Cloudera manager, let's log in. And where you set it in yarn. If I go to yarn, this is yarn, okay. I go to configuration of yarn. And if I simply search for reduce, read. Any MapReduce program you run, 3 reducers will kick in. That is useless. Probably the reason is that the administrator might be believing that you will submit huge MapReduce programs without mentioning the number of reducers. At least 3 can run, so it is easy to handle the load, right? So in my application, I did not write anything. So this will run 3 reducers. That's what I'm saying. It is unnecessary because we are doing simple word count. Doesn't make any sense, but 3 will run. Yeah. In the code you can override. I'll show you a different code. In the next class, we will run a airline delay program. Now the point is, I actually wanted to run that program this class, but when we ran, we ended up in an error. The problem is that data is 700 MB input file. So when I uploaded into Hadoop, it became 1.5 GB. And when I ran the program, it crossed the quota limit and the program didn't run. Everything is fine, but we have some restrictions. So I didn't check it also. I thought it will run just. So I talked to them and Great Learning said we will fix it in the next class. So when I'm running that, airline analysis MapReduce program, I will show you how you can manually ask for reducers. Like you want 4, 5, 6. How many you want, you can ask in your program. I'll show you that. So I think this part is clear. Our driver part is also clear, at least whatever we are discussing. And somebody was asking about imports. This is the imports. So these are normal Java imports. And look at here, import Apache Hadoop IO int writable, long writable, text. So this is integer, long and string, corresponding data types, okay, wrapper classes. And I'm also importing MapReduce.mapper reducer. Why? Because mapper and reducer are classes which you will inherit. If you're writing a mapper logic, you don't write it from scratch, you will extend it. You will already have a class where you can just extend it and write it. Okay, so that is why I'm importing these classes. This is the configuration object we created, and this is a job object. This is a text input format, text output format. File input format is the abstract class. Okay, file output format. fs.path is used to read the data, input data. So these many imports are there, standard imports. Most of the programs will have these imports. And here is your public class word count. So this is where your program starts, right? I'm in the public class. Now I create a class called a map. This is my mapper, which extends mapper, because mapper is your base class, right? I will tell you what is this. Okay, I'll tell you what does this mean. But if you look at the logic, just scroll down a little bit. If you look at the logic, I will read the data to a variable called line. I will call for a new string tokenizer, and I will open a while loop. I'll say while tokenizer has more tokens, I will say go to the next token. And finally, in order to write the mapper output, you will say context.write value comma int writable 1. So this is where you're writing word comma 1. This is the output. This context is an output collector in MapReduce. In Java, you have system out print like that. In MapReduce, you have a context. You say context dot, it can write the output, collect the output. So this is where you're actually saying that word comma new int writable 1, new 1. You're hard coding this. But what is happening here, right? This part. This is a very interesting part. This part. Even for non-Java guys, because I'll just copy this part. Give me a moment. Yes. So if you're another question is that how do I compile this? So in production, what we do, we will have Jenkins. You know Jenkins, right? It is a build engine. So you say you push it, it will compile it. Actually, it will download all the dependencies because you will be using Maven. Maven will have your pom.xml. One way. Second way that I used to do is that you have to download the Hadoop from Apache. It will have these jars. You will add it in Eclipse as external jar. You say compile, it will compile. Both is possible. These are external jars only. I mean, in Eclipse, it is added as an external jars only, not part of this. So you have to manually do it. So very rarely I have seen people doing like that, because in most of the projects, you will have this Jenkins guy. So you'll push through Maven only. That's easy for you because you can just add the dependency, right? It will say, I don't know what is an int writable, how to download all the jars and add it, right? But I just thought I will explain the basic stuff that you mean. So this piece of code I took from your original program, I just wanted to explain this, okay? Because see, what is our input data? So people who do not know Java could have been practically fainted out by this time by hearing the class names and interfaces and other things. That's okay. So this is my input data, right? Now, what did I tell you? I told you the mapper will read each line and then you wrote the logic, get every word. But I lied to you. That is not the actual way. There is a reason. MapReduce says, if this is your input data, you should give it as key value pair to the mapper. MapReduce says, you have the data, okay. This data cannot be given to a mapper as it is. It says, you first convert this data into a key value pair, then give it to the mapper. Honestly, I don't know why it is like that, but that is a documentation what it says. Now the question is, this is my input file, right? How do I further convert this into key value pair? That's not possible. This is my original data. I don't want to convert or do anything, right? So what happens is, when you are running the program, your framework will automatically convert this into key value pair. How? That's the question. So what is going to happen? It will add keys like this. So first key will be 0. Second key will be 16. Okay, based on the character position, right? So I'm just writing something. Okay, the numbers are not correct. Okay, just to prove, I'm just writing. Let's say 62. Let's say 77. Meaning each line it will look at the first character. What is the first character? A, right? The position is 0, 0th character. 0 will be the key. This will be the value, right? Now it will read 0, 1, 2, 3 up to 15. Next A will be what? 16. 16 will become the key. This will become the value. Meaning, if you mention text input format class, there is a subclass called record reader. What this guy will do, it will pick up each line okay, this record reader, it will convert them into this format and feed it to your mapper. So your mapper is getting data like this. It is not getting original data. The problem here is, this is key value pair. This is your key, capital K. This is your value. You are getting key value pairs into the mapper. So, and key is useless, right? Do we need the key? No, but something has to be added, so this was added, right? So in the mapper, I should say what? Process the value, right? That is what you see here. It says I create a map, long writable key, text, value and context and exceptions and all, value to string. Look at this line. You are converting the value to string and storing in this variable because the key is useless. So if you read the code, you should understand, right? This is a golden principle of MapReduce. Any mapper you look, even in Python, they will discard the key. Key is useless. Because the principle of MapReduce says the input to the mapper has to be key value pair. So the system will automatically generate some random key. In this case, it is numbers. Sometimes in Python and or sometimes we see some random numbers will be generated. Whatever is the number, you can discard it, take the key and take the value and process it. That is what you are writing here. And what is this big code? This says input is in the form of long and string. Output is again string and integer. This is the input format, key value. This is the output format. XML also, there is a random key generated. It is not the character position. I forgot what is there for XML. We have done very less XML processing. But even in XML, you discard. No. XML, you don't discard. XML, the root tag and row tag, it will identify as key. How is the structure of an XML file? You will have a root tag. Then you have row tag. Right? That is how the structure of XML. So it will identify them as the key and the corresponding data as the value. The row tag will be your key and whatever row tag represent will be your value. So it is like a table, right? Like an RDBMS table. The row tag is like a column header, similar to that. So there, if you want, you can keep the key because that is your row tag. If you want to process something, you can use it. Text file, this is the format actually. So it can start and end anywhere, but XML file processing is actually a bit complicated. For every raw tag, it will create a key. What it does, it simply read it and create a key. Then you have to make sense of that in your mapper. You have to read it and say that if this is the raw tag, do something. If here it is ending, do something. Because somehow it has to pass as a key value pair to the mapper. Otherwise, it cannot process. Right. This is the input to the mapper, right? So if I take this is one line. This is one line of input, right? If I just take it, if I want to represent this, can I say the data type can be long and string? Possible, right? That is this long, writable and text. So this is the input. But what is the output of mapper? The output of mapper will be, let's say arya, comma 1, right? One of the output. What is arya? String. What is 1? Integer. Right? Doesn't become. So you are saying that the input of the mapper is key value pair. What is their data types? Output of the mapper is also key value pair. What is their data types? You're just mentioning the data type of key and value. That is what you're doing. So these first two lines are input to the mapper. This is input to the mapper. Key is long writable, value is text. Output will be word, comma 1. Word is string, 1 is integer. The point is 100% it will be like this. I have never seen a case where you have a full line. Because you are splitting exactly at 128 MB. HDFS says I'll divide your file exactly at 128 MB. What is there at 128 MB? How do you know? Can you predict? It will be a new line character or end of a character. Can you predict? No. So the data gets stored like this. Now you have a real problem. What is the problem? Mappers run independently. One mapper will never talk to another mapper. Tell me what is your problem. Exactly. If the mapper runs here, it will consider Arya as a word. Second word will be Sa. This mapper will say NSA is a word and John. How do you solve it? Possible, right? Very much possible. So I thought somebody might ask this question. I mean, normally when I say everything works in a perfect world, but this answer is also a bit confusing. I'll try to convince you, okay, or I'll confuse you. One of that will work. Good question, right? You are storing a bunch of images. Is it guaranteed a block will have exactly 10 images? Then how does mapper will process? Okay, question. Can I take this line and add it here? This split line, why not? Yeah, it's already 128 MB. I cannot increase the block size, right? So, I mean, it's not easy to answer it also. Okay, and it is very difficult to convince also what is the answer. See, how do you know whether the block has incomplete data? Who will know? Who is knowing? Is it you, or is it Hadoop, or is it somebody in Hadoop? There is no data movement in Hadoop. We are not moving the blocks, right? Because that is extra processing. I have to move the block. Because every block will be like this. In MapReduce, before the mapper runs, there is a phase called input split. Input split is a phase, which will happen in MapReduce automatically. You don't have to do anything. It will run automatically before any MapReduce program you run. What is the purpose of input split? It is run by MapReduce framework only. Your logic was correct. It will analyze every block, and based on text data I'm talking, new line character, it will understand here it is split. And these blocks are having a sequence as well. It understands this is the place where the extra data is there. Step number 1, you identify there is a problem. The problem has been identified. But now the answer is very simple. What you need to do, you have to simply add this data here. Problem solved. Where does processing happen? In the hard disk or in the RAM? Yes. So this block will be read into the RAM. Once it is in the RAM, there is no block size, right? And it will read this over the network and add it here in the data node RAM. So all these blocks are in the RAM, and then the input split will run. It will understand that in this RAM there is a missing delta. It will read it from here and add it. It is simple and complicated. Because why it is complicated? If it is a simple data like ARIA, Sansa and all, it will work. For other type of data, you might have to write a custom input split. Meaning, try to understand. Let's say 3 line is 1 record. Here 1 line is 1 record. JSON or something. Then JSON built in there is a reader which will understand. What if you have your own format, file format? Your own format in your company, where your company says 4 lines is 1 record. If I want to process, I need 1 full 4 line. Then you have to write your own input split class and say that, hey, MapReduce, look for 4 lines which are not cut. If anywhere there is 4 lines cut, you add it. And you did not ask one important question. If you run a MapReduce program, how do you know how many mappers will run? You said depends on the number of blocks. Not really. Depends on number of input split. For example, if here I have 3 blocks and 2 mappers. Are you able to understand? There is a physical block here. But it has only a delta data. If while running MapReduce, this will be added here, right? Will there be a mapper running here? 3 blocks I have, 2 mappers will run. So this 2 is called input split. Logically, how many blocks of data you have? No, the blocks, inside the blocks data will be same only, right? Within the block I'm saying. I mean, this is a very rare situation, but you cannot always say that number of blocks are equal to number of input split. Always. It can be lesser. In this example, there are 3 blocks. The 3rd block is very small. But only for this data, why should I run a mapper here? I can add it here. That's better, right? In that case, 2 mappers only will run. 3 mappers will not run. You can control it also. And you can never control how many mappers you need. It is automatically decided based on your data. You can always control how many reducers you need. That is your control. So these points you need to remember when you go to Spark. Rather than writing a code that anybody can write. Even people without this knowledge can write a MapReduce code if they know Java. But these things actually matters. Because this is how your resources are utilized. When you run a MapReduce program, you will see suddenly 10 mapper, 3 reducer, from where all this came. Right? You should be able to figure out, oh, I have this. That is why the data is right. Like that. Now that poses a question. What is the size of a mapper? When you say mapper is running, typically in a Hadoop cluster, it uses 1 processor core and 1 GB RAM. 1 processor core and 1 GB RAM. That is what is allocated to a mapper. Right? Now let me ask you a question. If you are processing a lot of data in Java, normal Java, JVM, right? You have a problem of garbage collection and overloading and all, right? Here that will not happen because in 1 GB container, JVM, you are getting a JVM of 1 GB. You are loading 128 MB block. See, your data is only what? 128 MB, but the resource is 1 GB actually you're getting. Okay, so it can get enough space to run and process and execute actually. The default is 1 GB, you can change it. Here I am saying in one of those that is having every, so here I am saying one mapper is running, that is running in a container, a JVM with 1 GB RAM, that's what I'm saying. Yeah, so this when a JVM starts, it might load multiple blocks also. JVM is just a container. It can read this block and another block also, right? For another guy's program will be running. 1 GB RAM is there. Okay, another block can also be loaded by the JVM. It can track it, right? In that case, 2 blocks will be loaded from each, so ideally that is how it happens. 2 blocks will be loaded and that will be processed by the JVM. But again, the RAM is not the only thing that matters. Processor core also matters. A container will have a processor core also. So how many threads it can handle, that also matters. The processor has to process your data, right? So if it can handle 2 parallel threads, 2 blocks can be run inside a container, no problem. But if the processor can process only 1 block, even if you load 2 blocks, it doesn't work. Got it, right? Your processor core also has to be there. That is only in this case I'm saying. See, everything will be in the RAM only, but in this case, this line is broken, right? So I'm saying that this line can be added here to complete a single record. You need 1 line to process. 3 blocks you are not merging. 3 mappers are running on all 3, but this mapper gets only half a line, right? Only this line will be combined here. That will happen after shuffle and reduce, right? This is the mapper logic I'm saying. Before mapper runs, only input split happens. First you have to extract the key value pair, right, in the mapper. The final piece you will see only in reducer. Zip file cannot be directly processed. You have to uncompress and process. So what is corrupted, what is not corrupted depends on what is you want to process. In this, I want to process line by line. So if I get 1 full line, it is not corrupted for me. Am I clear? If I get single line of data, say Arya, Sansa, John, that is 1 record for me. Technically it is called a record. So when processing comes, you have to say record, right? In an Excel file, 1 line is a record. Same way, this is 1 record. So if this mapper looks, it says I have 4 records. I can count the words. 5th record is corrupted. So only this it has to add here to complete a record. That's what I'm saying. Yeah, so by default for text file, it is new line character, 1 line. But it already read this, right? So this will be communicated. When the input splits happen, input split will say that this line I am reading and adding here in the RAM. So don't process, start from here only. It is not mapper 1 which communicates because mappers will not communicate. MapReduce framework will inform. So it will produce these input splits in the RAM. Okay. So in the RAM, it is all getting processed, right? So if this data moves to the RAM, over the network, you're copying this to here. It's like a cut paste operation. This data doesn't remain here then. Because in the RAM, you're moving it, right? So it doesn't remain there. No, ideally, it will not be 1 mapper. Ideally, for 1 block, you have 1 mapper. The idea is that for 1 physical block, you run 1 mapper. And in that block, if you have a missing record, you get from others. You are not combining 2 blocks. If 1 mapper is combining these 2, then it can combine 100 blocks also. What is the use then? You are moving data over the network. You have to minimize the data movement. You have to minimize data movement. Yeah. Sure, I mean, I just took as an example. It might be this way also. This is just an example. It doesn't mean like always you are adding from here to here. It can be from here to here. Depends on the size of the data. Yes. So if here you have small data, it will push here. Because the idea is to minimize the data movement. Whichever way you can minimize the data movement, it will process. Unless you want to process your own custom files. Not the mapper code. This input split class is there where you have to write how does your file looks like and all. Mapper code will be standard only. This is happening before the mapper code runs, right? Mapper should get perfect data. It will not mess with the data. You can probably say my 1 record is 1 lakh lines. What will happen? Everything will load into 1 mapper and process it. That's also possible. The reducer code is similar. I don't want to explain much, but if you look at the reducer code, it has again a public void reduce where you are getting a text. This is the key. Then you have something called iterable on values. Iterable is a method which can iterate through the values. And then you have context. So what is that you're doing in the reducer? You will say sum equal to 0. You will open a for loop. This x.get method will get all the values. Remember, shuffle output is given to reducer. So shuffle will have a key and 1, 1, 1, 1, 1. So this x.get will get all 1, 1, 1. It will increment for this sum. So sum will keep on incrementing. You will get the final output. Same Java code, and finally you will say that key comma new iterable sum. You will call this sum here, you will get the final output. Now let's run the code and come back to this again. I want you to can you access the Cloud Lab? Can you check? Because the net was down, internet was down. Can you log in and see? Is it available? I am assuming you have your file here, right? This input.txt, is it space separated? Can you confirm? Yes, right? And if I do an ls, you should see this wcount.jar also. Can you see that? Yeah. Now, in order to run the MapReduce program, you will say yarn jar, and you will say word count.jar. This is the command. Yarn jar means you are submitting the jar file to Yarn. Yarn is the guy who is going to run it. Word count.jar. Then you say where is your input data in Hadoop. It is in del/input.txt. That is where the data resides. So you are passing it as an argument. Where is the input path? And once MapReduce program runs, the output has to be stored in a folder in Hadoop. Now you have to give a new folder name. If you give an existing folder name, the program will fail. What will happen? MapReduce will create a folder and dump the output. So I will say that I need the output in a folder. Let's call it as opt1234. Any name which does not exist. So I am saying that run the jar file. My data is in del/input. And once you get the result, create a folder called opt1234 in Hadoop, store it there. And if I hit enter, if everything works fine, it should run. Okay. See, number of splits 1, very important point. Input split, number of splits 1. It already calculated. It's a very small file, running job. So the job is running. Yeah. See, map 0, reduce 0. MapReduce phase started. Okay. Map 0, reduce 0. Now we'll say map 100 and reduce 0. Small data, right? You have only small. Map 100, reduce 0. So map phase is over now. Reduce phase is still starting. Reduce 0. Reduce 33. Because a lot of people are accessing the cluster, right? That's why. See, reduce 67, 33, 67. Reduce 100 and over. Program ran. So if you see this, your program ran successfully. This opt1234 is a folder. In the program, you can tweak it. You can say that if there is an existing directory, delete it. So it should have created this folder now. So if I go to my Hue, just let me check this whether it ran successfully. If I go to Hadoop, there is a folder called opt1234. If I open that, there are 3 files. Why 3 files? 3 reducers. Default number of reducer 3 in the cluster. I can't change it. I didn't change it. So that is why you see 3 files. That is not ideally required. Also, look at the way hash partitioner work. The 3rd file does not have any output. 3rd reducer simply ran. It didn't get any data. Because very small amount of data, my shuffle could have thought, let it go to 2 reducers only. 3rd reducer didn't get any data. And if you want to see the output, just click on this guy. John 21 was processed here. HDFS, DFS -cat. What is the folder? opt1234/star. So this command you can run from the command line. You are saying that show me the output of all the files combined in opt1234 folder. That is opt1234/star. Not really, because you are running multiple reducers. So the reducer output is not sorted. Reducers themselves internally will sort. Right? But now I have 2 reducers. So one guy was having John, right? The other guy was having Arya and Sansa. The other guy is having Arya and Sansa. This A and S is sorted. That is displayed randomly. So here it could have been sorted. Arya and Sansa will be sorted. Within a reducer it is sorted actually. I asked it to create a folder, right? I don't need to know the name of the node to get the file, right? Then my name node is useless. So I said show me the output of opt1234. So when you uploaded the input.txt, did you know where it went? That is where we run that files racks locations. Yeah. So if you run this, ideally, I will talk about this. There is somebody called resource manager. So a little bit about Yarn. Yarn is your resource management framework. So there is somebody called resource manager in Yarn. It is the master. So if you submit any program, it will go to resource manager. And this guy will decide how many resources to be allocated, where it should run and all, and will run it actually. So from the resource manager, you can see the logs, one thing. But more than that, if you are having Hue access, right? Yeah, so this is there. If you go to Hue, there is something called job browser. Can you see? Job browser, you can see the program which ran. Okay. See, this is the job browser will just show you all the jobs ran. So this is my word count, MapReduce, ran by GL faculty, right? It says map 100, reduce 100, everything was fine. If you click on this guy, yeah, it will say that attempts, right? 1. If you go to task, it will show you how many mappers, how many reducers ran. So 1 map was ran, 3 reducers were ran. Now, if I go to one of this mapper, let's say this mapper, if I click on this guy, I clicked on the mapper, okay, it says an attempt. If I click on this attempt, I'll get the details where the mapper ran. So the mapper actually ran on this machine, 20.031.239. This is where the mapper ran, right? And it says progress 100, succeeded, all the details, logs are available here in the mapper. So if you go to the logs, you can see all the logs. It says std out, std syslog, all the logs are available. Job browser is actually part of Hadoop only, okay? And Hue will just put it in a very nice UI and give it to you so you can track the jobs. So from here you can see how many mappers ran, reducers ran, any errors were there, anything crashed, everything. Command line, you have to look at yarn logs actually, and you don't have access actually, that's what you can see normally. Another thing, very important question, normally you will never ever in your life run a MapReduce job like this. You will not go and say, okay, yarn, jar and run. What you do, you will schedule it using Uzi. You will go to your admin and say that I have a program to run. He will say, I will give you Uzi. And in Uzi, so if you are submitting the code to Uzi, you don't need driver. Very important point, please make a note. You don't need to write the driver because the driver will be with Uzi. In Uzi, you can set, what is the text input, all these things you can set in Uzi as an XML. In Uzi, you simply provide the mapper class, reducer class, that's it. It'll run it for you. In Uzi, what you do is that there is a file called workflow.xml. In that XML file, you will define all the driver property. Same thing you wrote here, like what is the input format, output format, everything you will write there. And in Uzi, you will say, this is my mapper, this is my reducer code. You will submit the jar file and then you can schedule it. You can say every day 11 o'clock you run, it will run it for you. And that's what, you won't directly run from command line in a production network. Nobody will give you access also, don't worry. Now, if you are a Java guy, you can also do unit testing in MapReduce. The framework is called MRUnit. You could have heard about JUnit. It's an extension of JUnit. It's called MRUnit. MRUnit, MapReduce unit. You can run unit testing. So all the regular testing things can be done. There is MRUnit for unit testing. And then you have integration testing and black box testing, all these things. Testing, there is a separate team for all these things. I'm not from testing background, but there is a team actually who does. So you have a test cluster, which is exact replica of your production cluster. Otherwise, how do you do this, right? You created everything, you packaged a jar, you ran, the entire cluster crashed. So then you can't have such situation. So you have to debug and test it completely in a testing cluster. Then only you submit it in the production cluster. So once you submit in the production cluster, no error should come. Error can come, resource is not available like that. In the code and all, no error is accepted. Because you will very rarely get chance to again resubmit. Lot of people will be submitting jobs actually. In most of the companies, I am seeing that cluster is always busy, lot of jobs will be running, Spark, this, that. So you don't have time to again test and run in a production cluster, right? But it will be already written. It's not like every time you write it. So these are all business use cases, right? Say for example, when I was training people in Flipkart, okay, Flipkart used to have a MapReduce program. They used to collect all the logs from their website where people browse, okay? And then there was a MapReduce program which will read these log files. It creates some key value pair and then it will output like how many people search for white items or something. So this will run as a batch job because they will collect 3 days worth data. Third day, 12 o'clock, this program will run. So once you write a program, forever it runs. It is not like every time you're writing a new program. For the business use case, you write a program. That keeps on running whenever you want. If you're having things like Splunk and all, it can read. Okay. If you are using BI tools, I'm not 100% sure, like this Tableau and all, I think it has to be in a tabular format. You are learning Tableau, I think, right? Tableau I have not worked. Splunk I have worked. Splunk can read from any text style and visualize whatever you give. It's possible. Splunk can work with any type of data, even from HDFS. So there is something called Hunk. Hunk, Hadoop on Splunk. Splunk on Hadoop, sorry. That's called Hunk. So very weird names we have. Okay. You can Google actually. Hunk app we used to install. So Hadoop plus Splunk is called Hunk. So there is an integration between Splunk and Hadoop. It can easily read and write to Hadoop. So monitoring this job browser will help you to monitor. Right now the job run really fast. If it was a forever running job, one way is you can track from here. Another way, there is a resource manager UI, but I will try to fetch the UI. I don't have it right now with me. The resource manager UI, I will show you. From there, it will show running jobs, how much percentage it is complete, mapper 33%, 40%. You can figure out there is some time it is going to take.